Bismillahirrahmanirrahim. Assalamualaikum and very good morning. So today I'm going to explain about data flow and error control. Okay, in this chapter, I'm going to give a brief introduction of data flow and error control. Okay, link layer addressing, flow control, error control. Okay, and then the technique, we call this a technique for technique in data flow control. So we have stop and wait, go back and ARQ, and selective repeat. So these are the technique for automatic repeat request, ARQ. Okay, data link layer. Okay, as we know that data link layer, the duties are for flow control and error control, and also it provide link layer addressing. Okay, link layer addressing can be divided into three types. Okay, unicast, multicast, and broadcast. Okay, so unicast, what is the difference between multicast? It's just in terms of the representation of the address. Look at the second okay, the address is written in hexa number. So the second hexa number. So if the second hexa number is 3, then it is unicast address. If the second hexa is 2, then it is multicast address. If all hexa are F, then it is broadcast address. Flow control. Okay, so why we need to control the flow of the data. First is to tell the sender how much data that can be sent. Tell sender. Okay, the sender must wait for acknowledgement ACK from the receiver before sending more data. The flow of the data should not overwhelm the receiver. So that's why the sender need to know the capacity of the receiver of receiving the data, so that it would overwhelm receiver. Receiver use buffer, okay, as temporary memory to store the data before being processed. So it will receive and store in the temporary memory. Okay. Error control. This is the next duties of data link layer. So error control, it is used for error detection and correction. The technique detection and retransmission. So allow receiver to inform sender loss or damage frame. Coordinate retransmission by the sender. Okay. So in error control, we have automatic repeat request, ARQ. Okay. So anytime error happen, specified frame are retransmitted. Okay. So in ARQ, we have three mechanisms. The first one is stop and wait. The second one is go back in, and the third one is selective repeat. In stop and wait, we have different situation, and the first one is for normal operation. Means that in this normal operation there is no loss frame or no loss ACK frame. So every transmission is going well. Okay, so let's look at this figure. Okay, so we need to start from the receiver side, because the sender need to know what is being expected by the receiver. Okay, so the receiver request or expected or request request frame 0. Okay, so the sender will send frame 0. So when the frame 0 received by the receiver check either the received frame is correct or what is the expected frame. It's similar to the expected frame. So when frame 0 is received by the receiver or reached to the receiver, and the receiver check the validity of or the is it the expected frame? If yes, then it will accept and reply ACK frame to let the sender knows that frame 0 has been received and accepted by the receiver, and request for the next frame, which is frame 1. Okay, when the sender receives ACK1, so the sender knows that receiver request for frame 1, so that the sender will send the next frame, which is frame 1. When the receiver receives frame 1, it will repeat the same step. It will check, this is the expected frame? If yes, then it will acknowledge the sender that frame 1 is received and accepted by the receiver, and ask for the next frame, which is 0. And that is we call as normal operation. No lost frame, no lost ACK frame. Okay, the next the next situation, stop and wait ARQ for lost frame. So lost frame in this situation, okay, so we repeat the same step. Receiver expect to receive frame 0, sender send frame 0, frame 0 received by the receiver, check it is similar what is being expected, and accept. Okay, acknowledge to let the sender knows that frame 0 is received, and ask for the next frame, frame 1. Okay, so when the sender receive ACK, so the sender knows that the receiver has received frame 0 and accept it. So 1 means that the receiver requests for the next frame. So the sender send frame 1. But something has happened at the middle of the transmission process. Frame 1 is lost. The receiver wait for frame 1. Okay, still waiting. Okay, so here the sender won't receive acknowledgement from receiver because receiver has received frame 1 is lost at the middle of the transmission process. So what will be what action need to be taken by the sender? Okay, the sender has a period of time for waiting. Okay, when the time is finished or end, time out. Okay, here the waiting time. Okay, there is a waiting time. Okay, if the sender has received any acknowledgement frame from receiver within the period of time and before the time end, or after the time end, so the sender knows that, something has happened to the frame, the send frame, either the frame lost or something has happened to the frame, so that the receiver has received that frame. So what action that will be taken by the sender? It will retransmit. When the time out, the sender will retransmit frame 1. At the receiver side, there is no period of time, and there is no waiting time. It will wait until it receives the expected frame. So now it received frame 1, and this is the expected frame. So it will return or reply with ACK frame and request for the next frame. Okay, and that is the situation for the lost frame from the sender. Okay, the next situation is lost ACK frame. Means that the frame that being sending by the sender received by the receiver, but when the receiver reply ACK, that ACK frame lost at the middle of the transmission process. Okay, so the same same, the same period of time will be used by the sender, to take further action. Okay, here when the receiver requests frame 1 over here, the sender send frame 1. Okay, so the receiver receive frame 1 and accept, but the receiver, when it receive the frame 1, it will acknowledge the sender, that the receiver has received frame 1, but the acknowledgement frame has lost at the middle of the transmission process. Okay, at the sender side, okay, it's supposed to receive acknowledgement from the receiver. So here there is a waiting time. When the sender has received any reply from the receiver within the waiting time, the receiver assume that frame 1 has lost. So what will be happen to what action will be taken by the sender? When the time out, it will retransmit the same frame, because the sender assumed that frame 1 has lost, and that's why it doesn't receive any reply. It hasn't received any reply from the receiver, so it will transmit. But because of frame 1 has been already accepted here, and receiver has request for the next frame 0, and when they receive frame 1, what will be happen to the frame 1? By what action will be taken by the receiver when it receive the second frame 1? So it will be discarded, because the expecting frame is frame 0. So when they receive frame 1, okay, the receiver will reply ACK and ask for frame 0. Okay, so now the sender knows that the receiver has received frame 1 and asked for frame 0. Here, what I can see here, the sender doesn't has any idea what has happened. The sender has no idea what has happened to the receiver. Okay, either the receiver received the transmitted frame or not. The only point here, and the only information that the sender can assume or can make a decision is when it receives acknowledgement frame, it will take further action. If the sender has received acknowledgement frame, the sender has no idea what has happened to the receiver. Either the send frame or the transmitted frame is lost, or the acknowledgement frame is lost. Okay, this is the situation where delay ACK frame. Why delay? This happen when the ACK frame received after the timeout. Okay, so you can have a look on the figure. When the ACK frame is received after timeout, the sender assume that the transmitted frame has lost and it will retransmit the same frame. But at the receiver side, this is not the expected frame because frame 0 is already received and accepted. So what will be happen to the received frame? The second frame, the same frame, it will be discarded, and the new ACK frame will be transmitted by the receiver. Okay. The same thing will be happen at the sender side. Because here ACK1 is already received by the sender, and frame 1 is already being transmitted. So at the sender side, the ACK1 the frame of ACK1 will be discarded. Okay. Okay, the next one is piggybacking. So here both ACK and frame will be transmitted together. So look at the receiver side. Receiver side request for frame 0. Okay. So that the sender will transmit, both A and B can be sender and receiver. So both can transmit frame and both can transmit ACK frame. Okay, we are done with stop and wait ARQ, and that is the first mechanism, the first ARQ mechanism. Now let's look at the second ARQ mechanism, go back N. Okay, so in go back N, it uses the concept of sequence number, sender and receiver sliding window, control variable and timers, acknowledgement similar to stop and wait, resending frame is similar to stop and wait, and operation. Okay, first let's look at the concept of sequence number. Frame are numbered sequentially. For example, maximum frame number is M. So the sequence number range is from 0 to 2 to the power of M minus 2. Okay, let's say M equal to 3. So the sequence number is from 0 to 2 to the power of M. 2 to the power of 3, which is equal to 8 minus 1, 7. So the sequence number is from 0 to 7. So it will be numbered from 0 until 7, and it will be repeated 0 until 7, and so on. Sliding window, sender sliding window. So sender sliding window varies. It can be the size of 7 from 0 to 6, or it can be any size. Okay. This is the sliding window before sliding. This is the sliding window after, and the window after sliding to frame. At the receiver side, and the receiver sliding window has a fixed size, which is 1 before sliding, after sliding, and this is the expected frame to be received. So the frame that contained in the sliding window for the receiver side shows that the expected frame to be received. Okay, control variable, and this is at the sender window side, and this is at the receiver window. Okay, the size is different. The sender window, it can be varies. At the receiver, fixed to 1. Okay, so we have SF, first frame to be transmit, SL, last frame to be submit, R at the receiver, frame to be expected to be received. Okay, S is the recently sent, the frame that recently sent. Okay, now we go to the situation for normal operation. Okay, so look at the sender side and the receiver side, and the window size of the sender side is 3, Okay, the receiver side fixed to 1. Okay, now let's look. So we have, and the sequence of bits is from 0 to 3. 0, 1 to 3, then 0, 1 to 3, and so on. Okay, so this is the bit, this is the frame to be received, expected to be received. So this frame is in the sender window 0. So what action will be taken by the sender? Transmit frame 0 and the first frame. Transmit and then receive. Receive, check, accept, then slide to the next one. Shift to the next frame 1. This is the expected frame to be received. Okay, at the sender side, the sender doesn't need to wait for ACK to transmit for the next frame. It can transmit all the frame in the window, without the need for waiting ACK frame. So transmit frame 1. Okay, when the receiver receives frame 1, okay, so it will shift the window to the next 2. Okay, here the receiver would like to transmit ACK frame and request frame 2. When the sender receives ACK frame, what action will be taken by the sender? The sender will shift the original frame to the next, so that 2 will be the first frame in the new window, in the new sender window. Okay, so when they receive ACK frame and ask for frame 2, the sender will shift the window to the next, so that 2 will be the first frame, and then transmit frame 2 over here. Okay, when the receiver receives frame 2, it will accept, because this is the expected frame. Actually, receiver doesn't need to reply ACK frame, because the frame in the sender window size, in the sender window still got frame to be transmitted. Okay, but in the case of the receiver would like to transmit ACK frame, the sender will shift and the sender window size to the new window size and transmit further frame. And this is the next situation where lost frame. Okay, lost frame. Okay, the same process. Okay, the receiver expect to receive frame 0. When it receives frame 0, it will accept and shift the receiver window to the next one. Okay, here when it receives frame 1, receiver transmit ACK frame. When the sender receives ACK frame, it will move and shift the window to the next, so that 2 will be the first frame and the new sender window. Okay, when the sender transmit frame 2, something has happened to the frame and it lost at the middle of the process. Okay, 2 is the expected frame by the receiver. Okay, here frame 2, frame 3 and frame 0 is in the new window, in the new sender window. So the sender will just transmit all the frame. So start with frame 2 and then frame 3. Okay, but here when the receiver receives frame 3, frame 2 has lost, but frame 3 is received. But 3 is not the expected frame. What will be happen to the received frame, frame 3? Frame 3 will be discarded. Here will be discarded, and at the sender side got period of waiting time. So when the time out and the sender will retransmit, it would go back. It will go back to the first frame. Because it's already transmit all the frame, so it will go back and retransmit again. When the receiver receive frame 2, it will accept it, and because this is the expected frame at this moment. Okay, when it receive frame 2, so the receiver can transmit the acknowledgement, or the receiver just shift the window to the next. Okay, when the sender receive ACK, what action will be taken by the sender? It will shift the window to the next, so that 3 will be the first frame in the new window. Okay, this slide explain why the sender window size must be less than 2 to the power of m, or equal to 2 to the power of m minus 1. Okay, so here, if the window size is equal to 2 to the power of m, what will be happen? Okay, this is the expected frame to be received by the receiver. When it receive, so it will accept it and go to the next, shift to the next frame. Okay, frame 1. When it receive frame 1, it will accept and shift the window to the next. Okay, when it receive frame 2, okay, it will accept and shift to frame 3. Okay, and then when it receive frame 3, it will accept and shift to the next frame, frame 0. Okay, actually here, every for each received frame by the receiver has sent acknowledgement, but all acknowledgement has lost at the middle of the transmission process, because that the sender hasn't received any acknowledgement frame. The sender will repeat after the timeout. The sender will repeat and will go back to the first frame, and it will transmit 0. But this 0 is not similar to what has been expected by the receiver, and because this 0 has already been received and accepted, and the receiver expected to receive the next 0, not this 0. So this is the implication when the window size is similar to 2 to the power of m. So the receiver accept the wrong frame, even though it has the same number, but it is different. Okay, we are done with go back end. Now let's look at selective repeat, ARQ. So selective repeat is the most ARQ mechanism that been implemented, because by using selective repeat, it will reduce the use of bandwidth, because in selective repeat, it use NAK or negative ACK. So it means that the receiver only requests for the lost frame, the lost frame. Okay, use the same as sender window size, pipeline. Okay, here the sender and receiver window size has the same size. Has the same size. Okay, let's look at this example for lost frame. Okay, so the receiver expect to receive 0 and 1. So the sender transmit frame 0 and 1, transmit frame 0, receive, accept, transmit frame 1, receive, accept. Okay, and then reply ACK frame, request for the next one. Okay, when the sender receive ACK, it will shift the sender window to the next, so that 2 will be the first frame, 2 here. Okay, then when the window has been shifted, okay, the next action taken by the sender, transmit frame 2. But something has happened to frame 2, it lost at the middle of the transmission process. Okay, 2 won't be received by the receiver. Sender transmit the next frame, frame 3, received by the receiver, accept. Okay, but 2 is still missing. So what will be action taken by the receiver? Send a reply negative ACK request for frame 2. Request for the lost frame, the specific frame. Okay, so when the sender receive NAK, negative acknowledgement frame, and request for frame 2, the sender will resend or retransmit frame 2 only for frame 2. This already been received. So when the receiver receive frame 2, it will accept it. And that is a selective repeat lost frame uses NAK, negative acknowledgement. So request for the specific frame that hasn't been received by the receiver. Okay, so let's bring us to the last slide, which is the summary. So we have discussed about link layer addressing, flow control, error control, and the mechanism of ARQ, which can be divided into 3: stop and wait, go back end, and selective repeat. So I hope that you could understand from my explanation. So thank you for your time and have a nice day. Thank you very much. Assalamualaikum.